All right, let's do this problem called implement try. I think I've already covered it in another problem, which is I think called word break. But okay, let's do it again. So essentially, you gotta need to know what a trie data structure is, and if you already know that, then implementing it is quite straightforward. But let's quickly talk about uh, how the trie data structure sort of looks like. So essentially, trie data structure is used to save different words in a dictionary, and the way it says is that for every letter in the alphabet, you have a corresponding node. So let's call so essentially you have something called as a node, and this node has two informations. One information that it has is whether this node is an AND of word. So that tells you that there is a word that ends at this specific node, right? And the other thing is you have an array of size, whatever is the size of the alphabet. Let's consider lowercase English characters for this case. So of 26, and then you can call it next or something, or neighbors or something, right? That's a typical tree data structure. So if any of the corresponding is non-null, that means there is a further path from the direction. If the child is null, that means there is no further path from the direction. Let's take an example to understand what I mean by that. So let's take the root node, right? Let's take an example where you only have like maybe just three characters in your alphabet, or something, or and then let's take a word which is something like A, B, C. A is another word, and then BCA, BC is another word, and then BBBAC, let's say, is another word. So let's say these are these three words that in the dictionary are there. So what essentially the root node, uh, the root node will be a node which will have the AND of word as false, and will have like an array obviously of size 3 and initialized to all null, right? So initialized to all null. So this is your root node. And now when you are inserting this word A, that means the first guy, A, is non-null. So you associate, you give it a value, right? So in a simple format, I want to represent it like that. So this is A, and then you have a B, and then B has a C, right? And then C has a, right? That's a general idea. And then another word is B. So you also have another word which starts from B, and from B you have a C. From C you have A. Okay, I'll putting it A as here, but okay, fine. A, and then B, okay, and then C, right? Now let's go to the third word, which is B. So this is already B, and then another B, so another B, and then another B. So let's say there is a B here. So another B, and then an A. So this is an A, and then a C. So this is a C. So that is a sort a way in a way a representation of it, right? And using this information, you can do, and at every point where the word ends, so A B C A. So A B C A. So this node will be then marked end of word, right? So that you know that a word ends here. Similarly, B, C, A, B, C. This node will also be marked end of word. This node will be marked end of word. And B, 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 A, C, again, same end of word. It's already an end of word, so that's fine. All right. So let's quickly convert that into code in the given problem. So let's first define our node structure. So class try node. It has a boolean called end of word, and it has a an array, let's call it next of, depending upon the size, how many character, like what kind of lowercase English characters only. So then you can just use of size 26, initialize this to false. So when you do this, so in try, let's have like a root, maybe initialize to null, and when you're here, you do root equals to new try node. Now, when you want to insert into the try, what would you do? You start with the root. So let's say node equals to root, and then what you want to do is for each character C in word, you wanna check. So you get the node. So basically, you check if node dot next of uh, this character C, if this is not equals to null, sorry, if this is null, then you wanna create a new node here. So node dot next of C minus A equals to new try node, right? You wanna associate it like that, or it could be that it already existed. So in either case, you'll go to that node. So node equals to node dot next C minus A. So now you are at that node. Now what do you want to do with this node? Nothing. You are at that node. All good. And now we'll go to its next and so on and so forth, right? And at the end of it, whatever node you are on, you will mark its end of word to true. All right. So this is how you will insert. Then you want to be able to search. So again, sort of the same logic. So you start with try node equals to root, and then you go for each character C in word. You want to check if the node exists or not. If node dot next of this character, if it does not exist, then there is a problem already, right? And if it exists, then you just do node equals to node dot next, and you go to that specific. Why am I doing? Why am I doing capital A everywhere? All right, small a, small a, small a, small a, right? Node equals to node dot next, and at the end, you're looking for exact word, right? So the last node should actually be an end of word. Node dot is end of word, right? That is also essential information. Starts with, well, it starts with it exactly the same as search, except that, okay, it does not have to finish with the end of word. So here we were calling return node dot is of n. Okay, I'm feeling sleep. It seems node dot end of word. And here you say, okay, if you found everything, it's not necessarily have to be and a word. You just a prefix matches there, and that is sufficient. So that's all. Okay, let's run. Fix the errors. What's the problem here? It is calling it prefix. So prefix. Okay, run. Okay, submit. And it works. All right.